moment of inertia of circular section about centroidal axis. Now let us see what is the moment of inertia of a circular section about its centroidal axis. For this, we will consider a circle of radius r and center O. Okay, and I have drawn only a part of this, and we will consider a small portion like this. Okay, I will draw the radius here. Let this angle be theta, and this angle is d theta, and this area we are considering this area. Let this distance be r, and this be dr. That is, thickness of this small area is dr, and we know if d theta is in radians, this distance will be r d theta. That distance will be r d theta. Okay, so area of that elemental strip equal to, what will be the area? R d theta into dr. Is it not? R d theta is the arc length into the thickness or width of the strip will be equal to r d theta into dr. Okay, now let this be xx axis. We need to find the moment of inertia about xx axis. Now if I draw this portion separately, this is theta, this is r, this will be r sin theta. Is it not? That will be r sin theta. Is it not? R sin theta. So moment of inertia of this area about xx axis will be Ixx strip is equal to area, that is r d theta into dr into square of the distance r sin theta square. Isn't it? So this will be equal to, that will be equal to r into r square r cube d theta dr into sin square theta, and it can be written as r cube into 1 minus cos 2 theta by 2 into dr d theta. Sin square theta can be written as 1 minus cos 2 theta by 2. 1 minus cos 2 theta by 2. So into dr into d theta. Now to find out the whole moment of inertia of the whole section about xx axis, we need to integrate this expression, that is I xx is equal to, there will be double integral because r is to be integrated through the whole distance, that is through r, and theta is to be integrated through the whole circle, that is 2 pi radians. So there will be two integrals. It will be a double integral, 0 to r, 0 to 2 pi r cube into 1 minus cos 2 theta by 2 dr into d theta. This will be the integral. It will be a double integral. So we can write it as equal to integral 0 to r cube dr into integral 0 to 2 pi 1 minus cos 2 theta by 2 into d theta. So this will be equal to r raised to 4 by 4 from 0 to r into 1 by 2 into theta plus sin 2 theta by 2 from 0 to 2 pi. Okay, this will give you r raised to 4 divided by 4 into 1 by 2 into theta from 2 pi will be 2 pi minus 0 0 plus sin 2 into 2 pi, that is sin 4 pi by 2, that is sin pi, sin 2 pi, sin 4 pi, all are zeros, therefore 2 pi, and minus is also, it's also 0, therefore it will be sin 2 pi. So this will be equal to r raised to 4 divided by 4 into pi, or it can be written as pi r raised to 4 by 4. Now we know r is equal to d by 2. R is equal to d by 2. So this will give you pi into pi by 4 into d by 2 raised to 4. This will be pi by 4 into d by 16, and ixx is equal to pi d raised to 4 by 64. That is ixx. So moment of inertia of a circular section about its centroidal axis is ixx is equal to pi d raised to 4 by 64. Pi d raised to 4 by 64. Then what will be iyy? It will be same. It will be iyy also.